Okay, so the first example, we knew the population standard deviation, and you usually do that when like you have a current system where you have data and then you want to test to see if some change improves that data. That happens sometimes. This type of example happens a lot as well. So we have a new system. They want to look at conductivity materials, conductivity properties of materials. And these are the conductivity measurements for 11 randomly selected pieces of a certain glass. So that right there tells me that my sample size is 11, and it gives us the information right here. Is there convincing evidence that the average conductivity of this type of glass is greater than 1? I'm going to erase that because we're going to have to use that here in a second. So let's define that. Mu is the true average conductivity of this type of glass. That's my dog in the background. Sorry, y'all. I just chat. All right, so I want to try to prove that this conductivity is greater than 1. So my null hypothesis is that that is not true, and my alternative is that it is true. All right, so we will then set our distribution to be centered at the null hypothesis here. I want to know, is this standard deviation, is this sample mean in my rejection region? Okay, so significance level of 0.05, but I don't know the population standard deviation. I'm going to have to use S as that approximation here, which means I need to use a t-distribution with 10 degrees of freedom. Now we're going to let StatCrunch do all of that work for us to find our critical value and make this evaluation. But it's important for us to know this so that we do the correct test. All right, so let's go ahead and go into StatCrunch. I'm going to go ahead and split screen this so that we can have both of these here. Okay, so I need to enter in this conductivity rating data. Okay, so those are my 11 measurements. And when I go to stat, I need to make sure I go to t-statistics. That's really important that I use the correct distribution. One sample, and I actually have the data. I plugged that data in, so I'm going to use with the data. All right, variable 1 is where the data is. My hypothesis test equals 1 and then greater than 1. Yes, please show the critical value. Here is the significance. I'm not going to worry about plotting it because I'm going to just do that here. Okay, so it does all of that for me. Sample mean, degrees of freedom. All right, the critical T, this benchmark, is 1.81. And our T statistic, this is that critical value, if you will. Okay, and so our T statistic that we find is the sample mean minus 1 minus the distribution mean all over, and then this standard error takes into account S over the square root of n, and that gives me 2.01, which is in my rejection region. And I get a p-value of 0.0359, which is less than our alpha level that was given to us. Okay, so we can then write our response. We reject HO. We have sufficient or significant evidence. Significant evidence that the true mean conductivity of this glass is greater than 1.